Welcome to VW 6.3. Today we're starting our study of rational functions. So first, we're going to see it says find the domain of a rational function. So for these, for a domain, your frame of mind is going to be this. Think about what x can't be. That's going to be much easier to think about than what x can be. So if I look here, focus on the bottom, and just think, what is the value that x can't be? And I can see that'd be -5 because -5 would make the bottom 0. So we're going to use set notation for this. X such that x cannot be -5. And remember this notation, this simply means all x such that, and that's clearly x can't be -5. For this problem, I'm going to look on the bottom, and I can see that x can be everything except for 2 and -2, so that's what we're going to write. X such that x cannot be plus or minus 2. And this one's interesting. X squared plus 1. If you were to try to solve that for it to 0, notice how it really can't be done with the real numbers. You'd get imaginary solutions. Right? So there's no real solution here. In that event, that would mean the domain is everything. All real numbers. So that's our first step, finding domain. And again, that's really nothing new. We have done that before. Here's where it gets a little bit harder. Finding the vertical asymptotes. So recall a vertical asymptote. It's essentially like a vertical line like this, where whatever graph we're working with is going to approach it. So something like this, or like that. In order to find them, this is what we're going to do. You look at your denominator, after simplifying. And that's really key, because it's going to seem really easy, but the key is you have to simplify it. So for this one, you're going to look at the bottom and think about what makes that 0. So just like our domain problem, I can see that 1 would make it 0. And I can't simplify any further, so you're just going to write your VA, your vertical asymptote, is x equals 1. So notice how it's pretty easy. So for B, same thing. I can see I can't simplify any further, so look at the bottom. Your VA is x should equal 2 or -2. For part C, notice how the domain here would be everything. So for your vertical asymptote, there would be none. There's no way to make the bottom 0 here. So at this point, it's looking like it's pretty similar to domain. However, it's not the same. The key is right here. You must simplify the function first. So if I look at D, a little more complex, I can see that this is factorable. The top is x plus 3 over x minus 3. And the bottom is x plus 7, x minus 3. Now if I ask for the domain, you would simply say it's x such that x cannot be -7 or 3, just like you did earlier. However, for the vertical asymptote, you have to simplify it. So you're going to get rid of these x minus 3's, and now you look at what's left. This is your simplified function, right there. And you look at this thing to figure out your vertical asymptote. So look at the bottom here, and that would be x equals -7. Okay, so that's it for vertical asymptote. Notice how it's very similar to domain, except you just have to simplify first. Now the last part is the most complex part. We're going to talk about horizontal or oblique asymptotes. And I put slant there because some books will call it a slant asymptote. So to do this, we have to talk about a few rules. So right above your problem, we're going to write HA rules here. And this is a generic function. Ax to the m plus dot dot dot. Bx to the n plus dot dot dot. Notice how we only care about the leading terms. So put focus on your LTs. There are three cases we're going to talk about. Case 1 is that m equals n. So we're going to focus on the exponents as well. That's going to help you think about what's happening. In the event the exponents are equal, these two, what happens is that your horizontal asymptote is y equals a over b, meaning you simply just take the coefficients. Case 2 is going to be m is less than n, meaning the top is less than the bottom in terms of the degree. In that situation, your horizontal asymptote would be y equals 0. And case 3 is going to be m is greater than n, meaning top is greater than the bottom. In that situation, for HA, there would be none. So let's just focus on that for now. So for this first one, focus on the exponents. I can see the bottom is greater, which means I am in case 2. So for HA, you would simply say y is equal to 0. Now, if you're wondering why this is happening, we're essentially just plugging in a big number, like we're plugging in infinity. So imagine you actually said, let x equal infinity. What would happen is, because it's x to the 5th, this number would be so huge, and it'd be so much larger than this number, that you're going to approach 0. Now let's go to the next one. Right here, I can see that the powers are equal. So in that instance, what's going to happen is you just take the coefficients, 8 over 4, so HA is y equals 2. And again, what's happening is we're saying, let x equal infinity, and because the powers are equal, everything will basically cancel out, and you're left with your 2. And for this one, this is case 3. I can see the top is bigger, and I look at the exponents here, which means for HA, there is none. Okay, now if this part for infinity is not making sense, we can talk about it in class, and I can try to explain it further in person. It'll be easy to understand when we're together. Now notice how we didn't do the final part, this oblique or slant. That's going to happen in case 3. This is when your oblique asymptote occurs. Now it occurs when there is no HA. And what we're going to do to find it is we're going to actually use long division. So back in Algebra 1, you should have learned long division, and now we're going to use it again in Algebra 2 to figure this thing out. So what you're going to do is, hopefully you remember long division. Make a house, 3x to the 4th, and we need placeholders for the terms in between. So I'm going to put 0x squared minus x squared, 0x cubed minus x squared plus 0x plus 0, and we're dividing it by x cubed minus x squared plus 1. And let's just divide. So this should be 3x. Now you multiply 3x to this thing. So you get 3x to the 4th minus 3x to the 3rd plus 0x squared here. And then this would be 3x. And we subtract the quantity, and we get 3x cubed. This would be minus x squared and then minus 3x. Now we're going to complete it. We can see I need a plus 3, because if I have plus 3 and I multiply, I'm going to get 3x to the third minus 3x squared. That's going to be plus 3. Subtract, and I'm going to get 2x squared minus 3x minus 3. And this right here is your remainder. So plus 2x squared minus 3x minus 3, all divided by x cubed minus x squared plus 1. So of course that seems pretty long, but the cool thing about your oblique asymptote is you only care about this right here. You don't even need the remainder. So we don't even need that. This thing is your oblique asymptote. So we're going to write your oblique asymptote is y is equal to 3x plus 3. And that's it. So if you have any questions, let me know in class.